All right, let's see properties of limit. So these are the properties of limit. Let f and g be two functions and assume that the limit of x approaches c of f of x is L. The limit of x approaches c of g of x is m. So there are around 8 property of this limit. That means if the function is continuous, you just substitute the value and get. But if the function is not continuous, you have to be careful. So if there is a constant, the limit of a constant is a constant itself. If it is x, then substitute the x, which is c. And if it is addition, you have to apply the limit to each function. If it is subtraction, make sure to keep the sign and substitute. If there is a constant, take out the constant. If it is multiplication, apply the limit to each function and multiply. And if it is division, the same thing, apply on top and bottom. And if it is square root or any nth root, you have to apply the limit on the function which is represented inside the radical or any other root. So in order to clarify, let's use this example. This is evaluate the limit. So here I have to evaluate, let's say, according to the rule. Let me use black one. Limit of x approaches to of x squared, and I have to apply limit of x approaches to of 3x. This becomes, since a continuous function, 2 squared minus 3 times 2, then this one is 4 minus 6, which is minus 2. All right, the second one is also, look at this, limit of x approaches negative 2 of the first one plus limit of x approaches negative 2 of 5x. So this is negative 2 the whole square plus 5 times negative 2. This is 4 minus 10, which is negative 6. This is the value of the limit. So just applying the rule. For a polynomial function, you have to plug in the values into each terms. Let's see this one. For example, this means limit of x approaches to x to the fourth minus limit of x approaches to 3x squared plus, limit of x approaches to of 1. The last term is a constant. So 2 to the fourth minus 3 2 squared plus, the limit of a constant is a constant itself. This is 2 times 16 minus 3 times 4 plus 1. This is 32 minus 16 plus 1. So 32 minus 16 is 16 plus 1, which is 17. That is the limit. When you do this one, you have to apply inside. So the cube root of, this is the cube root of 2 limit of x approaches 1 of, x to the fourth minus 3 limit of x approaches 1 of x squared plus limit of x approaches 1 to the function, the constant function. So this is written as 2 times 1 to the fourth minus 3 times 1 squared plus 1. So this is the cube root of 2 minus 3 plus 1. Now you can see that this is negative 1 plus 1, it is 0, then the limit becomes 0. So you can see that applying the rule, you have to apply the limit to each of the terms. Now let's see this one, rational function. The same thing, we have to apply limit of x approaches to on the top side divided by limit of x approach to on the bottom side. So this is 2 times 2 plus 3. This is 3 times 2 plus 2. The top one is 4 plus 3 is 7. 6 plus 2 is 8. So the final answer is 7/8. All right. The same thing you can do for this one, applying limit of x approaches -1 on x to the fourth minus 2 limit of x approaches -1 to x plus limit of x approaches -1 to 3. This one is -1 to the fourth minus 2 times -1 plus 3, because the last term is a constant. It is 1 because this is even, you know. So this is plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. This one is limit of, under radical x approaches 2 of 3x squared minus limit of x approaches 2 of 6. This one is under radical 3 times 2 squared minus 6. So this one is 3 times 4 is 12 minus 6, which is radical 6. So do you see the rule and apply to each limit? Let's do this one. Limit of x approaches -2 of x squared over limit of x approaches -2 x squared plus 1. The top one is -2 the whole square. The bottom one is -2 squared plus 1. This is 4. This is 5. So it is 4/5. So in the next video, we'll discuss about the limit of a piecewise defined functions.